What if you stumbled upon a small, often circular lake in an otherwise flat landscape, far from any river or typical drainage? These unique depressions hold a fascinating story of ice age power. Kettle lakes, also known as kettle holes, form specifically in glacial environments when isolated blocks of stagnant glacial ice become partially or completely buried by sediment and then melt, leaving behind a distinctive depression that fills with water. This process begins during glacial retreat. As a massive ice sheet or glacier recedes, it often leaves behind large, detached pieces of ice, sometimes referred to as dead ice. These blocks can be huge, ranging from a few feet to several miles across. Meltwater streams flowing from the glacier carry vast quantities of sand, gravel, and other sediments, depositing them as outwash plains. These sediments often accumulate around and on top of the dead ice blocks. The overlying sediment acts as an insulating blanket, protecting the buried ice from rapid melting. This insulation allows the ice to persist for hundreds or even thousands of years longer than exposed ice. Over time, as regional temperatures warm and the insulation is breached or thins, these buried ice blocks eventually melt. When they do, the overlying sediment collapses into the void, creating a steep-sided, bowl-shaped depression. These depressions then gradually fill with rainwater or groundwater, forming the characteristic kettle lakes we observe today. The size and depth of a kettle lake depend directly on the original size and depth of the buried ice block. For geologists and keen observers, identifying a kettle lake often involves looking for its typically circular or oval shape, steep banks, and frequently the absence of a visible inlet or outlet stream. They are common across formerly glaciated regions, particularly within outwash plains and moraines, serving as clear indicators of where ancient ice sheets once lingered. The term kettle itself likely derives from the resemblances of these depressions to the shape of an old-fashioned cooking kettle. These features provide invaluable data, allowing scientists to reconstruct the extent and retreat patterns of past glaciers, offering a crucial window into paleoclimate. They are not merely pretty ponds, they are geological time capsules. Understanding kettle lake formation connects the immense power of moving ice with the subtle, slow processes of melt and deposition, revealing how dynamic our planet's surface truly is. They stand as enduring, tranquil monuments to Earth's icy past, continuously shaping the landscapes we explore and study.